Hello, in this section we'll talk about the context random variable. And as we talked about in the last section about the discrete, difference would be just that if you remember between the discrete and continuous, at discrete you have a specific points while the continuous you have an interval. So it will be like this. The first one is like you have like a lines, but they are separated by the density have a curve. In the continuous word you get the word density while in the discrete you have the mass uh, function. So to make sure that it's a probability density function, we have two things to make sure of it, like the discrete. First, that the total value between the interval will be 1, and that probability of every interval inside the big interval is between 0 and 1. So usually you have this probability of A less than A and B is the interval of X. So first example we have that suppose that f of x is equal to e to the power negative times x minus 4, and where the x is bigger than 4. So the first thing we need to do is to make sure that f of x is a probability density function. So at first, the first thing we'll do is substitute from 4 to infinity, which means that x bigger than 4. And doing the integration, we will get that we have this negative to the times t as the integration result, and the rest will be the same. And substitute, so e to the power negative infinity is 0 and e to the power 0 is 1, so we'll get 1. So that's a correct probability density function. The first asking about is x bigger than 1, and as we don't have interval from 1 to 4, we will get the x bigger than 4. So the first result will be what? Will be also 1. Okay, so x bigger than 4. The second one asking about x from bigger than 2 till 5. We don't have a value from 2 to 4, so we will start from 4 as a first order value. So we have from 4 to 5. The third equation is asking about from 8 to 12, and this we have interval 4, so we'll get interval from 8 to 12 and get the result for it. The fourth will be x less than 5, but as we have only value less than 5 interval, it is from 4 to 5, so we will do a calculation for it. So the second example we have is that f of x equal x over 8, where x lies between 3 and 5. So the first thing, as usual, we will do, we will make sure that the probability density function is equal 1. Okay, so that you get used it in the first exercise. So after that, and we make sure that x of x is equal 1, we will get to the required things. So the first is x less than 4, and x less than 4, as previous example, we do have only the interval to 3, so we'll get the interval from 3 to 4. Okay, so this is first that you will get the interval from 3 to 5, which is, and last you will get 1. And the first asking about that you will get the interval from 3 to 4, and you do the integration, and you get the probability. The second thing asking about bigger than 3.5. So if you remember from the previous section, when we had a question asking about f of 1.5, we said that we don't have 1.5, so we get less than 1.5, which is 1, until we get the results of it. However, in here we have an interval, so we can get 3.5. We can match from 3.5. So we'll get here 3.5 till 5. Okay, and we get the interval. The next one is x less than 4.5. So less than 0.5 we have also 3 to 4.5, and the last one you have here this or this, and if you remember, or means plus, so you have 3.5 till 5 and 4.5 till 5. Okay, and this is our results here, and you collect the two probabilities for them easily. The next concept we have is a cumulative distribution function. And the cumulative distribution function is like the previous one, that you accumulate the results. And here is a feature important here in the continuous, which is that the density function equals, this is density, equals the derivative of the cumulative. So if you give you, for example, x squared and say that's the cumulative distribution for your function, then if he asks about the density, it will be what? The derivative. It will be 2x. Okay? So we have the first example here, that f of x equals f of x is this. So you have this function as a cumulative, okay, and then you have this interval 0 where x less than -2, and quarter x plus half if you have -2 till 2, and 1 when x bigger than 2. And also is about find probability of x less than 1.8 and b from -1 to 1 and so on. So the first one, you will do what? Here x less than 1.8 lies where? Lies here in the second one. So substitute in the second function. Second one, you have here 1 and -1. You have a specific interval, not less than or bigger than. Here is trick part. So I will draw again what I erased. Show you what I'm meaning. Imagine that you have this distribution, okay, and you have here 1, and you have here -1, okay. So less than 1 means what? Means this, okay. All the values lies in this. And bigger than -1 would be means what? Means this, okay. I want this interval. This is the line between, okay. This from this to this. So I will say what? I will get the probability of x less than 1, and I will substitute it to be 1. So probability of 1, negative probability of -1. Sure, it is x less than -1. As I did the substitution, I inverted the inequality, okay, to get the interval. So here is this probability of x less than 1 minus probability of x negative than 1, and the check where it lies in an interval. It will lie in the second, so substitute and get this. X bigger than 1.5. Again, as we did here, we can get the bigger or we can get lower. So we'll get what? 1 minus probability of x less than -1.5. Okay? So you get here 1 minus this quarter x plus half, and you get the result. There is asking about probability of x equal 1. And here, if you remember, one of the features of the continuous that you can't get a specific point. So there is something called equal 1, because there is no density, there is no area for a specific point, but there is an area for a specific interval. So if you give a value for a point, it will get 0. And the last, asking about the BDF. And here's a BDF, is probability density function. So if you remember this feature, we did what? The derivation. So derivative of 0 will be what? 0. Derivative of quarter x plus half quarter. Derivative of 1 is 0. So the last thing, you will get what? Quarter to value of x between 0, -2 till 2. Okay? this is relative to only. The last concept we have is the expected value and variance. If you remember from the previous section, we have the expected value is what? Summation of x times p of x. Here's a difference, a slight difference. It will be integration instead of summation. Integration of x times f of x. And the variance will be what? The same concept we have in the previous section. So, the first example, we have this f of x over a from 2 to 5. So we'll get what? I'll find the x times f over a from the interval of 3 to 5. X will be x squared over a. So after the integration, it will be x cubed over 54, and I get the result here is 4. The second thing we do what? X squared to reach the required for that x. So x squared will be what? X squared times x over 8 will be x cubed over 8. Then the integration will be x over 4 over 2, and you will get 16. And then the variance will be the subtraction. So it will be 17 minus square of 4, it will be. And another example is that we have 2 times x power 3, so it's given 1, and asking about the expected value. So we'll do what? We'll substitute this. Okay. This will be 2x minus 3, and this will be what? So it has expected value. This has, alright? And then the result will be